Hi there, I'm Kathleen Jasper, and today we're working through our Praxis Math 5161. We're still in numbers and quantity. This is part 3 of our series. The slides for this presentation are below in the description. Let's get started. All right, so we are still in the numbers and quantity content category in the first section of the exam, and we're actually going to be, if you can hop over here to my computer, we're actually going to be in numbers 5 and 6 right here in the specs. So if you're following along with the specifications at home, which I hope you are, we are in numbers 5 and 6 under content category 1, and we're in the number and quantity section. Now, just a quick disclaimer here really quickly. This is kicking my butt, and I want to share this with you because I know many of you are studying for this exam and you're feeling defeated. I will tell you, preparing for these videos is really complicated, really hard. I'm falling on my face a lot. I'm getting frustrated, but I want to share that with you guys because I know that's happening to you too. And if I can get through these problems and I can make presentations for these problems and work through them, so can you. So, this particular, I mean, we're not even in the hard part of the test yet, and it's killing me. It really is. But I'm determined to move through these specifications. I'm determined to get through every single skill with you guys and work through it. And hopefully you guys learned something along the way. But definitely wanted to share that because I'm sure some of you are falling on your face today. And that's just the way it goes when we're trying to learn new things and trying to do hard things. We can do difficult things, okay? Now, the other thing I want to tell you is a lot of this math you probably haven't seen since like senior year in high school, maybe junior year in high school. And so this has kind of brought me back to those days that I was hoping I would never see again, but turns out I have a job now that I have to do this type of math for. So I want to bring to your attention some resources that are available to you. Now, you may already have accessed these resources, but I want to bring these to your attention because I am not an expert in this area, as that is probably perfectly clear to all of you. I do understand the test and the specs and the skills, but you may need some more support beyond what we're offering here on our YouTube channel. So if you go to the page, the Praxis ETS page, for Mathematics 5161, you can see here, that's where I am here. We have the study companion, which I'm going over every time we work through this, but we also have this study resources Word document here. And I really like this. You can download it and you can see here, it's a full-on study plan with all the resources for each spec. Now I know this is a lot, so let me zoom into the first page here. Now they say numbers and quality here, but it's actually number and quantity. It's a little typo in their resources here. No big deal. I make typos all the time. I just want to bring it to your attention so that you're not like, well, you said quantity and this says quality. It says quality here. It says quantity in the specs. I'm going to go with the specs because it is the document. So it must just be a little typo. No biggie. Everybody makes mistakes. And I'm probably going to make a few here while filming this video. But I really like this because you can see here, the specs are all broken down by skill, and then next to each one there is a video from Khan Academy. Now I know some of you have emailed us and saying like Khan Academy is too much, I can't understand it. I totally get that. I'm using Khan Academy while preparing for these videos. So I'm basically listening to Sal Khan go through all this stuff. He's a great teacher, and he's got a great YouTube channel. And I'm kind of dissecting it so it applies strictly for this test. And I know you guys want that. You kind of want it extracted and just worked through on the exam. But if you go in here and you need some more help, these videos are already pulled out for you. And he even has some practice with the videos. So I would say my videos that are specific to the skills on the test, plus this is really going to help you prepare for the exam, and probably, you know, a book, a study guide or something like that you can do. But here you can see we're going to be in this right here. Understands how to work with complex numbers, solving polynomial equations. We're going to work in that. And then for number 6, we're going to be working in matrices, okay? And he's got all the videos there, each one for each one of these, A, B, C, D, all the way down. Now, I'm going to go through a bunch of these problems with you today, and you're going to see them this way on the exam probably, but there's extra practice here. I recommend going through that if you need more, and we will link up this document in the description below so you have it. So Khan Academy is a great resource. We use it here to prep ourselves, but just wanted to let you guys know that. All right, so another thing I want to go over really quickly with you for this number 6 content category here, number 6 subskill here, when it talks about matrices. Now, when I purchased the ETS practice test, it has 60 questions similar to what you're going to see on test day. There were no matrices, I should say, on that practice test. However, now when I took the ETS practice test that I purchased online, there were no matrices on that exam. At least I didn't see any that I can remember, and I poured through that exam. However, look at number 6 here. This whole thing from A to all the way down to G here is all dedicated to matrices. So it's really important that we go through it, because you might be saying to yourself, well, I took the practice test and there was nothing on there about a matrix. Well, yeah, maybe not, but it's here and it's a big part of the spec. So I want to make sure we cover it pretty well today. We're also going to work in this part here, number 5, the polynomials, but we are going to spend the bulk of our time here because it's a bigger piece of the specs. Okay, so that's the rationale for what we're doing today. All right, so let's jump right into it. We're going to go through 10 practice questions today that align with the specs that I just showed you about. The first 3 questions are going to be about polynomials and complex numbers. We're going to start with an easy one and then we're going to get more complex. All right, let's start with number 1. Choose the 2 solutions to the equation below. Well, right away, I can see that this is a polynomial in standard form. And I kind of had this disagreement with my husband about what this is called. You know, it is called factoring. We're going to factor out a 2 here, obviously. And then what I like to call it is reverse FOIL. But he told me that reverse FOIL is not a thing and that I shouldn't say it. But I really feel like it helped me understand this. And so I am going to call it a reverse FOIL today. I'm going to share it with you. If you're a math teacher, you might be mortified right now that I said that. But it's the way in my head I'm learning how to do this stuff again, because I haven't seen this since, like I said, high school. Now they probably do this in 7th grade, but back in my day, they did this in high school, okay? So let's go ahead and factor out the 2 right away. So I can look at my answer choices here. I'm looking for 2 solutions. So there's going to be 2 answer choices that I have to choose here, which can be kind of complicated. But I can see here, this is a polynomial, and I can factor out the 2. So what I'm going to do here is I'm going to take the 2 out, and this is going to be x squared plus 5x minus 14 equals 0. So notice I just took the 2 out, factored it out. If I were to distribute this back in, it would be 2x squared plus 10x minus 28. Okay, same thing. Now what we're going to do is the reverse FOIL that I was talking about that my husband says is not a thing. So basically he calls it AC method, but which is the way you're supposed to do it. But I just like to do it this way. We have this 14 here, and it's we have a negative here, and we have a 5. And so we need to make sure the factors of 14 add to 5 in some way, shape, or form. All right, for a negative 14, the factors can be, let's just say, a positive 7 and a negative 2, because this is going to be a positive 5 here, right? So 7 minus 2 is 5, or negative 2 plus 7 is 5. So the factors work there. All I need to do is bring down this x, and that's why I call it a reverse FOIL, because remember, FOIL is first, inner, outer, last, remember? But this is kind of a reverse FOIL. Of course, my husband says that's not true. It's the AC method, but whatever. I just think that it's easier to talk about it in this way. So now that we have this, basically what I'm going to do is set both of these quantities to 0. So this is x minus 2 equals 0 and x plus 7 equals 0. Well, when I solve for x, I add 2, x equals 2, minus 7, x equals negative 7. So I'm going to grab A and B. Those will be my 2 answer choices because it asks for 2 solutions, and so that'll be A and B. Now I left them as A and B here. They may be boxes that you check on the exam, something like that. It might say something like choose which could be a solution for the equation below, and maybe then you only have to pick one, and it's either x equals 2 or x equals negative 6. But either way, now you know how to do this particular question, right? All right, let's go to number 2 now. If A, B, and C are real numbers where A is not equal to 0, which of the following would result in the solution of one real root to the equation ax squared plus bx plus c equals 0? So this is your standard form for a polynomial. And in this case, I can see right here in my answer choices, and remember, we always want to look at our answer choices, we're going to be using this equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Have not seen that since junior year in high school, I'm sure. I'm sure I'm not the only one. Now, it says here we're looking for one real root. Now, if we go back to our first questions, notice there are two real roots here. Here they call them two solutions, but they're real numbers, so they're roots. So 2 and -7 are real. And so this one has two solutions, but we're looking for a situation here where we only have one real root. Now, right away, I'm going to tell you that in order to get one real root, it has to be equal to 0. So A is going to be your answer if it's one real root. If you're looking for two real roots, this has to be a positive number. All right, and I'm going to work this out for you so you can see how it all goes. But there needs to be a positive number. It needs to equal a positive number. What we're basically doing is we're taking this piece of the equation or of the formula down here, and we're making it equal to these things here, either 0, 10, -10, or -100. Now, if under that square root sign, this whole square root sign right here, if that's a negative number under there, or anytime there's a negative number under there, what did we say in our previous video? And if you haven't gone back and watched that, please do. You're looking at imaginary numbers, which are not real. So for C and D, I can automatically cross those out because they are not going to result in real solutions or real roots. They're going to result in imaginary roots, okay? So let me show you how this works out. So let's start with the imaginary roots first. Let's work from the bottom up here, okay? So I'm taking just this section here, all right? So I have square root of b squared minus 4ac. This whole thing is going to equal -100. So that means under this square root, I have -100 plus or minus, right? X equals plus or minus, x equals b, negative b plus or minus. So if this is -100, remember what I said, we have to pull out that I, right? Because you can't have a negative number under the radical sign because it's not real, it's imaginary. All right, so when we take out that I, because I equals the principal square root of -1, we're essentially taking out a -1. So now we have square root of 100 I, which is the square root of 100 is 10, so this would be 10I. But because this equation is x equals -b plus or minus, x equals -b plus or minus, there are actually two imaginary roots in the solution to this because we have this plus or minus here, 10I. And so that's going to be the case for C and D. So we can cross them off right away because if there is a negative under the radical, and we take out the I and we work it out, we're always going to have imaginary solutions, not real solutions. So this term here, real, is really important. So right away, I can eliminate -10 and -100, all right? So because that is the way for -100, it's going to be the same for -10, so I crossed that one off as well. Now let's go to B. Let's take a look at what it would mean if everything under that radical is 10. So I have x equals -b plus or minus 10 over 2a. Now, because we have this plus or minus here, and because 10 is a real number, we're actually going to have two real solutions here. If we worked this out, we would get two real roots or real solutions here. So that one is not the answer because we're looking for one real root. So we'll cross that one off. And now let's do the last one, or A, which is the correct answer. Let's take a look. If we have x equals -b plus or minus 0 over 2a, well, all this is -b over 2a. There's no more plus or minus because it equals 0. There's plus 0 is the thing, and minus 0 is the thing. It's -b. -b plus or minus 0 is -b. So there's only one solution or one root to this particular this particular equation here when it equals 0 underneath the radical sign. So that's A. Now, the quickest way to do this is like if you're looking for one real root, it needs to equal 0 under the radical. Not the whole thing is equal to 0, just under this particular needs to equal 0 there, okay? That will give you one real answer, one real solution, one real root, okay? Now, if it's any other positive number, you're going to have two real roots, because when you do negative b plus or minus 7 over 2a, or negative b plus or minus 2 over 2a, whatever this number is, whether it's a 10 or a 2 or a 7 or an 8, whatever it is, you're going to have two real roots or two solutions to that particular thing because the plus or minus there. Now, if we do it for this negative 10, remember again, we've got negative 10 under here, b plus or minus, negative b plus or minus 10 over 2a, negative 10, I should say. Pulling out the I, right away, I know it's imaginary. It's imaginary. It's not real. It's imaginary. So 10 is out, but let me just show you. We've got square roots of 10 over 2a, b plus or minus, negative b plus or minus. You've got two imaginary roots there. And the same thing goes with square roots of negative 100, negative b plus or minus. We're going to take out that I, and we have 10i because it would be the square root of 100i, which is the square root of 100 is 10. So 10i over 2a, negative b plus or minus. So that would be two solutions, but they would be not real. They would be imaginary solutions. So this lines up with the specs, and let me show you where that is right now. So this lines up with the specs when we say solve quadratics equations with real coefficients that have complex solutions. Remember, these are all real coefficients, but the complex solutions are right here. Remember the 10i, anything with an I is a complex number. So, and here we've got it here again, complex numbers, see? And we've got, theorem of algebra for quadratic polynomials with complex numbers. So that's what it looks like here. All right, so we're looking at number 3 here, and we have a polynomial that we're working with complex numbers here. And I know that 10 does not have factors in it that add up to 2. So I'm going to need to use this equation. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now I'm just going to plug in these numbers. So we're going to make, this is a, this is b, and this is c. A is 1, b is 2, c is 10. Right? So let's get into this here. So we have x equals negative b, so that's going to be negative 2 plus or minus square root of 2 squared, because b is 2, minus 4 times a, which is 1, times c, which is 10. And that's all over 2a, or 2 times 1. Now let's work this out. X equals negative 2 plus or minus, well, what's 2 squared? That's 4. And then I have a negative 4 times 1 is negative 4. And then I have that times 10. So this is negative 40 all over 2 times 1 is 2. Now I have this 4 minus 40 here. So this is x equals negative 2 plus or minus square root of negative 36 over 2. Now we know that with negative 36, it's an imaginary number. It's not real because you can't have a negative under a radical. So I'm going to pull out that I, which makes this positive. And so I'm going to have x equals negative 2 plus or minus square root of 36i, and that's all over 2. Now I like this 36 here because it comes out evenly, and I'll be able to solve this a little bit easier. So we're going to have x equals negative 2 plus or minus 6i, because the square root of 36 is 6, and I took that I out before, all over 2. If I'm looking at my answer choices here, I don't see any 6s or 2s. I have to reduce this fraction. And when I do, I divide 2 into everything here, and I get x equals negative 1 plus or minus 3i. There it is, C. All right, so it is a process. Probably on the exam, it'll be kind of even, like that negative 36. You know you're going to have to use these imaginary numbers. They're in the answer choices. You got to look at those answer choices, and that's going to help you out here, okay? All right, let's take a look now in terms of matrices or a matrix. Now, people use matrices for all kinds of different things. Probably most recent, or what people use them the most for, I guess, right now is like gaming and building computer programs, which we are not going to do today. But there are ways in which matrices can represent real world problems. And in fact, that is part of the specs. It says use matrices to represent real world situations. So that's why I created this question here. So I can see right away, if you see something like this, we're talking about a matrix, all right? And this matrix is actually a 2 by 2 matrix. It has 2 rows and 2 columns. That's how you do it. Something like this is a 3 by 2 matrix because it has 3 rows and 2 columns. If we were to add, let's just add one more column here, and this was a 10, 2, and 0, this would be a 3 by 3 matrix. All right, that's all it is. You go row and then column when you're determining the dimensions of the matrix, okay? Now, that'll become more clear in a minute, but let's talk about this here. So we can see that we have a word problem, and it's asking me, I'm going to go right to the stem. I always like to do that. Which of the following statements are true? Choose all that apply. And I'm looking at matrix here. All right, so let's look at the question. The starting salaries for 2 similar positions in 2 separate cities are different. The starting salary for an administrative assistant in Miami is $18 per hour, and the starting salary for an administrative assistant in New York City is $25 per hour. The starting salary for a store manager is $27 per hour in Miami, but in New York, the same position is $32 per hour. All right, so we're looking at 2 separate positions, administrative assistant and store manager, and both of those have different salaries in 2 different states. Now you can see here, this is the matrix here. The following scenario can be encoded in the following matrix. So S can just mean for salary. Salary equals 18 in Miami, right? And 25 in New York. And so we have that here, 18 in Miami, 25 in New York. And then we have 27 in Miami for the store manager and 32 in New York for the store manager. So in this case, the matrix goes like this. This is Miami, this is New York, and this is, let's do AA for admin assistant, and this one is store manager. So the columns are the cities, and the rows are the positions. Okay, that's how this matrix works. Now you can structure the matrix differently, and I'll show you that in a minute. So if we do this, let me just fill in my matrix here. 27 and 32. All right, so that's how it's done there. Okay, so that's how it works. Now, let's take a look at what it's asking. It says, which of the following statements are true? Choose all that apply. All right, so we're going to leave out the ones that don't apply and choose. So this is a more than one answer. Okay, the following matrix can be used to represent the above scenario. All right, so I can see here that it's not the same as this here because my numbers are a little bit different. But let's see, like I said before, you can structure this differently. I could put the positions at the top, and I could put the cities as the rows. I could make the positions, the columns, and the cities as the rows. Let's see if that's what they did here. Now I have 18 and 27. That looks like starting salary for an admin assistant in Miami and a starting salary for a store manager in Miami. So that looks like it's going okay. So we have 18 and 27. This is position, and this looks like it's Miami. So this is going to be Miami. And then we have 25 here, and then 32. And so let's see, 25, admin assistant, and then 32 here. So this looks like it works. New York, starting salary for admin assistant is 25, and in Miami it's 18, and a store manager in Miami is 27, and in New York it's 32. So this matrix works out as well. So I'm going to say yes to this particular one here. I'm going to circle that or check it. All right. All right, let's take a look. I'm going to erase a few things here because we're getting a little bit crazy with all of my stuff here. All right, so let's go to this bullet here. S2, comma 1, they're saying equals 27. Now, when we talk about the subscripts here, we're talking about row 2, column 1. So this is going to be row, so here's your rows right here. So let's say this is, let me draw this out really quickly. This is 18, 27. Remember, we're looking at the original problem here, not this one here, but the original here. Okay, so 18, 27, and then we have 25, 32. So which is row 2, so this is 1, 2, and this is column 1, 2. So we have row 2, column 1 is 27. So row 2, column 1 is 27. Looks like this bullet is correct. So A and B, or 1 and 2, are correct. Now let's look at this subscript, S1, comma 1. So that is row 1, which is 18, column 1, which is 18. That would be here. And this says 25. So no, that is not true. And let's look at this bullet here. We know none of the above is not true either because we have 2 that are correct. So we can get rid of that one. And let's go here. A change in the starting salary of an administrative assistant in New York can be represented by the matrix here. All right, so we're changing the administrative assistant in New York. So the administrative assistant was $25 per hour. So we need to change the 25 to something else. And it looks like we did. We changed it to 30 here. But let's see if the matrix is set up correctly here. So I have 18 and 27. So this looks like, it looks like we've got, we have our, let me draw this out, 18, 27, make it a little bit bigger so we can work with it here. So in this case, we have 18 and 27. That's going to be Miami. So we've got the positions here and the city here. And then we have New York here, which should have been $25 an hour. And this was $32 an hour. And it looks like, yes, this is represented correctly because we changed this 30 from 25 to 30, but everything else is lined up correctly. We have 18 as the administrative assistant in Miami, 27 as the store manager in Miami. We have 30, which is the change from the 25 admin assistant in New York and then this 32 for store manager. So notice that it lines up. Now, if I flipped anything around and moved this 30, over to here or is in the wrong place, it wouldn't work. But in this case, it does work. So dot number 1, dot number 2, and dot number 4 are correct. 1, 2, and 4. The other ones are incorrect. All right, so I did this problem because you're going to see matrices talked about in the real world and things like that. And this is kind of the way they're going to be set up for you there. All right. Now let's take a look at some more matrices. Now we have this undefined. You might see something like this. Which of the following is undefined? Now, I put this problem here for a couple of reasons. I want to show you ways in which we multiply matrices, ways in which we add and subtract. And so they're all in here so we can figure that out in one question. First of all, we multiply matrices a little bit of a different way than we do normal numbers. But the way it has to be in terms of matrix is you have to have the same number of rows in order for it to be defined, in order for it to be possible when we're talking about multiplication. So let's take a look at A. We have 3, 1, 4, 6, and we're multiplying that by 0, 1, 0 on the top and 1 at the bottom. Now, this is the way we multiply matrix. We take this 3 here and we multiply to this 0, and we take this 4 and we multiply to this 1, and we add them together to get that first column. So 3 times 0 is 0, and 4 times 1 is 4. So this equals 4. And then we have the bottom one, we have 1 times 0 is 0 plus 6 times 1, which is 6, and that equals 6. So A is defined. We can define it. Now let's take a look at B really quickly so we can see how we would add matrix. Now the way we add matrix is we add this number, and then this number and this number. And the same with the bottom. We add the 1 and the 1, and then we add the 6 and the 2. So that's how it works. And you have to have all the same rows and all the same columns. Remember, addition and subtraction are pretty strict here. And that's what we have to do. Now I'm going to work this out for you, but just know that B and C are defined because we have the same number of columns and the same number of rows. And that's really important when it comes to addition and subtraction. With multiplication, you just have to have the same number of rows. You can have a bunch of different columns and it'll all work out. But you need to have the same number of rows and columns for addition and subtraction. So let's take a look at that. We have 3 plus 2, which is 5. And then we have 4 plus 0, which is 4. And then we have 1 plus 1, which is 2. And then I have 6 plus 2, which is 8. So this would be the solution to that. All right. The same thing goes with subtraction. Let's take a look at the subtraction. It looks like I have the same number of columns and the same number of rows. So this is going to work out here. So we've got 3 minus 2 is 1. And then we have 4 minus 0 is 4. And then we have 1 minus 1 is 0. Then we have 6 minus 2 is 4. So the solution to that subtraction matrix is that there. And again, we have the same number of rows and the same number of columns. So we're okay there. Now with D, we got a problem. With D, just erase so you can see a little bit better. With D, we have multiplication, but remember how I do the multiplication, or I'm multiplying the same number of rows. Here, I have 3 rows and only 2 rows here. D is going to be my answer because we're looking for the one that's undefined here. Now let's take a look at how we would do it with E here. This is fine, but we've got multiple columns and multiple rows. All right, let's do E, okay? So I'm going to take it out a little bit. I'm going to draw it out here for you guys because just to make it a little bit easier. So 3, 3, 1, 4, 0, 1, 0. And then we have the column 1, 2, 1. All right. So basically what we're doing here is we're taking this here and we're going to multiply it by this here. And when we do 4 times 1 is 4 plus 3 times 2 is 6 plus 0 times 1, which is 0. Now we're going to do the same thing with the other column. We're going to have 2 times 1 is 2 plus 1 times 2, which is 2 plus 1 times 1, which is 1. And the last row, we have 3 times 1, which is 3, plus 4 times 2, which is 8, plus 0 times 1, which is 0. Now add these all up, and I get 10, 5, and 11. That would be the answer there. But we're looking for the undefined. I'm just showing you in this question that you can do different things like that. All right. So that's how you multiply. I showed you how to add matrices. I showed you how to subtract matrices. And I showed you what it looks like when it's undefined. And with undefined, you just have to have this lopsidedness. All right. And if you're on the test and you see something that looks weird and they're looking for something undefined, just as a lucky guess, you would go with D because it looks kind of awkward. It's not lining up like the other ones are. All right. All right. Let's go to number 6. Now, number 6 is a little bit different. We're looking for negative 3a, and this is going to be multiplying by a scalar. All right. So if A equals the matrix 3, 4, 1, 6, find negative 3a. Well, basically what we're going to be doing here is we're going to be multiplying the whole matrix by this scalar here. So it's almost like distribution. In fact, I would call it distribution, although I don't know if that's what it's technically called. But we're going to, if we're solving for, if we have a here and we're looking for negative 3a, we're going to multiply this whole thing by negative 3. And when we do that, we get negative 9, negative 12, -3, -18, because we essentially just multiply this whole thing in, and that's where you would write it in, -9, and my numbers are too big to write it in there, but you may get questions on the exam where you have to write it in, and that's all you do for that one. You just multiply it through and distribute it through each and every column, okay, and row. All right, now we have an addition one here, just like we did before. This one's pretty simple like the one before. So we have 4 plus 1, which is 5. And then we have 5 plus 0, which is 5. And then I have 2 plus 6, which is 8. And I have 8 plus 2, which is 10. That's going to be the answer there. Easy peasy. I have the right rows, the right columns. I can solve it. You're just taking each one and adding to the corresponding column and row. All right? Very easy. Now let's take a look at something like this. This one might be a little more complicated. So for this, I'm going to just label these A and B because we're going to be using some algebra to move things around right here. It's saying solve the equation for X. Write your answer below. So we need to isolate this X. And right now, I have a bunch of things on one side of the equal sign, and I have a bunch of things on the other side of the equal sign. What I really need is that X alone, just like in any normal isolation or any normal algebra problem where we're isolating the variable. So how would I do this? If this was 1/2 X plus A equals B, right? How would I isolate the X? Well, I would subtract A, right? And I would get 1/2 X equals B minus A, and then I would multiply by 2, and then I would multiply by 2, right? And that would give me the X. That's exactly what I'm going to do here. It looks a little bit more complicated than it is. So let me delete that, and let's go in here. So if I'm going to rearrange this so that the X gets by itself, I'm going to have 1/2 X, and this is going to be equals the matrix -3, 8, 9, 5, minus A, right? Because that's what we did here. 1/2 X equals B minus A, right? When that was part of our algebraic equation over there, or our algebraic thinking, I guess you would say. So we have minus 3, 6, -2, 4. All right? And we just subtract normally here. So I have 1/2 X equals, so -3 minus 3 is really -3 plus a -3. And we are going to get -6. And then I have 8 minus 6, which is going to be a 2. And then I have 9 minus -2, which is going to be plus 2. So 9 plus 2 is going to be an 11. And then I'm going to have 5 minus 4, and that's going to be a 1. So I have 1/2 X equals -6, 11, 2 over 1. And now what I'm going to do is multiply both sides by 2. And so basically I'm multiplying this by a scalar of 2. And this becomes -12. This becomes a 4. This becomes a 22, and this becomes a 2. And I would write that into my spot there, okay? So that's how you would solve for X when you have something like that. Now, if this said, if this wasn't a 1/2 X and it was a 2X, well, then we would divide everything by 2, right? So that would be a little bit different, or multiply everything by 1/2. So that would be a little bit different here, but that's how you use the matrix when it comes to solving for this particular variable. All right, so we may have to do some transformation vectors on the exam, and that's part of the specs. So let's take a look at this one. The transformation position vector X is defined by the following matrix. Plot the result of position vector Y for Y equals, and then we have its column matrix there. Now, all you have to do if you're presented with something like this is you just take this result and you're going to multiply it by this matrix here. So we've got 2, 1, 1, 1. I'm just going to make this a little bigger so we can see the multiplication a little bit better. And we're going to multiply this by the position vector Y. And so when we do that, we have 2 times 2, which is 4, plus 1 times 1, which is 1, which equals 5. And then we have 1 times 2, which is 2, plus 1 times 1, which is 1. That equals 3. So now we have the position 5, 3. Now the way we plot this on the plane, remember this is going to be our y and this is going to be our x. The top number is x and the bottom number is y. So if I were going to plot this on this coordinate plane, I would go over 5, 1, 2, 3, 4, 5, and I would go up 3, 1, 2, 3. And then the way you do a vector is you take it from the origin, which is 0, and you just draw an arrow like that to the dot. So all we're doing here is when you get something like this, you are just taking the matrix they give you and you're multiplying it by the column matrix that they give you. That gives us this result here, and then you plot that on the graph just like you would x comma y, right? And this is 5 basically comma 3. And that's what we did here. And the way the line works is, it's not really a line, it's a vector. And don't ask me why it's that way, it just is. And you use it as just a one-sided arrow there coming from the 0, all right? All right, so now let's take a look at how we might use matrices to represent systems of equations. This is super simple. So you might get something like this. Which of the following matrix equation, that should say matrix equation, represents the system of equations below? So we have 2s minus 5t equals 7 and negative 2s plus 4t equals 6. So you probably remember these. You can add these together and the s's cancel out, and then you can solve for t, and then you can solve for s. You probably know that from previous sessions. Now, for this, we're not looking for an answer to this. We're looking for a way to represent it in a matrix. Now, the way you do that is you take out the coefficients and those go in your first part of, in your first matrix. So let's do this here. What we do is we take out the 2 and then the 5. Actually, that's a negative 5, be careful, and a negative 2 and a 4. So we pull off those coefficients. Then the next matrix is going to be the variables, s and t. There's only 2 variables, s and t. And then the last part is going to be your sum or your solutions here, 7 and negative 6. That's how you would represent this as a matrix. And so that means that B is going to be the correct answer here. None of the other answers work. This is nonsense, nonsense, nonsense. So if you get a question like that, where it says, which of the following matrix equation represents the system of equations below, you're going to pull off the coefficients. Remember, the coefficients are what are in front of the variables. So I'm going to pull that off. I've got a 2 and a negative 5, and I have a negative 2 and a 4. So those come out into their own matrix. And then I have S and T. We only have 2 variables here, so S and T go there, and then we have 7 and negative 6 at the end matrix there, all right? So again, it looks way more complicated than it is. It's actually very easy. I definitely recommend going to Khan Academy, looking over there. They have very extensive video library of all different ways in which you would use matrices. He gets into a lot of things that you're not going to be tested on, but it's pretty interesting. You can fall down several rabbit holes there. But hopefully this helps you for the way it's going to be presented on the test. What I tried to do today was take these concepts and work them in different ways so that no matter how you see them on the exam, you will be prepared for the test, all right? All right, so that was a tough one. It's only going to get harder. Be sure you like and subscribe if you're enjoying the content. Tell your friends we're doing the Math 5161. Be sure to download the document in the description because that is the problems here with the answer explanations. And let us know if you need anything and we'll be happy to help. Thank you so much for tuning in and have an awesome day.